Determine an equation of the inverse of y equals negative x squared plus 4. So I'm going to rewrite that out in blue. I'm going to switch colors here. To find the equation of an inverse the equation of an inverse is a reflection over the line y equals x. It'll always be that your x's and y's are going to get switched. So I just take the equation, and where the y was, I write an x. Where the x was, I write a y. Now, I want to get the y by itself. There's my y. Right now it has a squared. I'm going to first get the y squared by itself, and then I can get rid of squareds by square rooting. So, to get that y squared by itself, well, I might move the y. It's negative here, so maybe I'll move the y squared to this side. I'll move my x. So I switched my y squared to the left and my x to the right side. And then I can get y by itself by square rooting. And of course, super easy to forget, but when you square root both sides, you have to add a plus or minus. This is the equation of the inverse. Now in part B, it says sketch the graphs of both of them. And I'm going to sketch them separately. I'm going to draw two different axes here. I'm going to start with the easy one, negative x squared plus 4. Parent graph would be a parabola, x squared. Makes sense that the negative would be a vertical reflection and then shifted up 4 units. So my graph would have the point 0, 4, 2, 0, negative 2, 0, negative 1, 3, and 1, 3. So a lot of this year is how quickly can you draw a graph from what you've known from before. You could also use grade 11 and say, I know my vertex is at 0, 4, it's opening down, over 1, down 1, over 1, down 3. That's perfectly fine as well. But now I'm sort of getting into the habit of transformations. I thought of my regular parabola, the negative would flip it down, and then I shifted it up 4. So there's my graph. Now to graph the inverse, I could either graph this equation, or easier would be to just take my normal points that I had to begin with and switch all my x's and y's. So instead of having 0, 4, I now have 4, 0. Negative 1, 3, and 1, 3, I'm going to have 3, 1, and 3, negative 1. 2, 0 will now be 0, 2, negative 2, 0. I just switch the x and the y's. And it took this parabola, and now this parabola is opening up sideways. Okay. I'm going to do a couple of things, but first we'll quickly answer part C. Is the green one, which is the inverse, does it pass the vertical line test? No. there are lots of x values that have more than one y value. Now, what I want to point out is what, I'm going to recircle this in green. The equation of the inverse, that's that graph. I'm going to take this equation of the inverse and I'm going to, that plus or minus really means you have two different equations. One with the plus and one with the minus. Now plus or minus is actually two different equations. Do you see two different square root graphs? Right? If I color code the top in purple and the bottom in orange, do you see that they would both be square root graphs? I have a +4 here, but it looks like it went 4 to the right. Why isn't it going 4 to the left? Because both of these aren't in factored form. So if you wanted to graph from the equation, you'd actually have to do a fair bit of work. You'd also have to I forgot the negative here. So this one, is this the purple side or is this the orange side? That's your positive square root. You would have a horizontal reflection, which would flip it over the y-axis, and then move 4 to the right. Can you see your regular square root? I'll just draw it. Here's my regular square root graph. Can you imagine that one flipped over horizontally and then move 4 to the right? Match up perfectly with the purple one. The orange one is this equation. Can you see flipping it horizontally, then flipping it, first flipping it vertically, then flipping it horizontally, and then moving it 4 to the right? You see that it would match up with the orange graph. Both flips, and then move 4 to the right, would match up with the orange graph. Isn't it much easier just to take the original points and switch your x and y's? Absolutely. Okay. This is going to be the best strategy for graphing the inverse is often graph the original and just switch your x and y's to get your new points. Because if you tried to do it from the equation, look how many places you could screw up. Right? The factored form shows up. You have the plus or minus, so you have to do two different graphs. It could get complicated if you tried to graph it from the equation. Okay? And because there's two equations, that's one of the reasons why it's not passing the vertical line test. Now, mathematicians don't like things not working that way. Okay? This is one of the reasons why the square root graph is only this red part. Technically, if you did the inverse of a parabola, a regular parabola, you'd also get the bottom part and have a sideways parabola. But then it wouldn't work on your calculator as a function. So when your original graph doesn't pass the horizontal line test, that means your image graph of your inverse won't pass the vertical line test. Mathematicians have restricted things to make it work. And that's what we're going to see in our next example. Okay, but first of all, you can circle questions 5 and 6.